Why are A, B, C important in algebra's quadratic equations? Have you ever wondered why the letters A, B, and C are so important in algebra's quadratic equations? Let's break it down in a simple way. A quadratic equation is usually written as a times x squared plus b times x plus c equals 0. Each letter plays a unique role in shaping the equation and its graph. First, let's talk about A. This letter is the coefficient in front of the x squared term. It cannot be 0. The value of A determines how the parabola looks. If A is positive, the parabola opens upward, creating a U shape. If A is negative, it opens downward, forming an upside-down U. The size of A also affects the width of the parabola. A larger absolute value of A makes the parabola narrower, while a smaller absolute value makes it wider. Next up is B. This coefficient multiplies the x term and influences where the parabola is positioned along the x-axis. It plays a key role in determining the location of the vertex, which is the highest or lowest point of the graph. The vertex is important because it helps us understand the maximum or minimum value of the quadratic function. B also affects the axis of symmetry, which is a vertical line that divides the parabola into two mirror image halves. Now let's discuss C. This constant term is the number without an x attached. C tells us where the parabola crosses the y-axis. This point is known as the y-intercept. Knowing the y-intercept is helpful when graphing the equation, as it gives us a starting point on the graph. Together, A, B, and C completely define the quadratic equation. They allow us to use the quadratic formula to find the roots or solutions of the equation. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. By plugging in the values of a, b, and c, we can calculate the x values that satisfy the equation. Understanding how a, b, and c work together helps learners see how changes in these values affect the graph and solutions of quadratic equations. This knowledge is not just useful in math class, it has real-world applications too. For example, in physics, quadratic equations can describe the path of a thrown ball or the trajectory of a rocket. In engineering, they can model structures and designs. In economics, they can represent profit and cost relationships. So, the next time you see A, B, and C in a quadratic equation, remember their importance. They shape the equation, influence the graph, and help us find solutions. Understanding these coefficients opens up a whole new world of possibilities in algebra and beyond.